Welcome back, students. Welcome back to the video lecture on CAD, AutoCAD. In yesterday's class, we have studied about the previous class. We have studied about the detailing of simply supported beams, cantilever beams, one continuous beams, where we have detailed detailing of all the beams were done as per their load coming over it, and depending upon the deflection of beam, the reinforcement has been laid, and we came to know how the reinforcement will be laid for that. In today's class, we are going to study about the slab, detailing of slabs, that is one-way slab, one-way continuous slab, two-way slab. So one-way slab, when we say that a slab is in one-way form, as you have studied in your RCC, a one-way slab means length divided by the width, that is Ly by Lx is greater than 2, then we say it as a one-way slab, and if Ly by Lx is less than 2, we say it as a two-way slab. And two-way slab means the main reinforcement will be in the both the directions, where we get deflection in both the ways. But in one-way slab, the deflection will be on only one side, so the main reinforcement will be laid on the shorter span, where we get the deflection for the slab, and remaining span will be of distribution bars. And this in one-way slab, the longer span will be supported over any of the support conditions like wall or beam, so the deflection takes place only in the shorter directions. Let us know, we can have a clear guidance over that, how the problem, by taking problem we'll come to know how we can the reinforcement will be made for this. So taking one of the problem here, one-way slab has been provided for a hall of clear dimensions by 3 meter by 7 meters, which is supported on a wall of 300 mm width. The main reinforcements are 12 mm at 150 mm center to center. The distribution reinforcement is 8 mm at 150 mm center to center. Draw to a suitable scale plan, section along the longer span, section along the shorter span, and given is the slab thickness of 150 mm. So what to be done here? The first step, a size of hall is given, that is 3 by 7. So when we say it is a one-way slab, when Ly by Lx is greater than 2, so Lx is 3 meters, Ly is 7 meters, so 7 by 3 it is greater than 2, so obviously it is a one-way slab. Copy, the thickness of wall is 300 on both sides. So this is the thickness of wall. Let us take it like this, so we can show it in this form. So we can see we are showing the section in the shorter directions. Just I am showing the dimensions here, how we get. We can write the dimensions here also. I will show you how we can write. The thickness of slab is given as 150. Yes, show it is 150. It is 300 because 1:50. Let us take is 1:50. We can see it is the thickness is 150 here. So when we take a dimensions for this bottom one, again it is 3 meters. So consider it as you can see here 3 meter by 150. And the thickness of wall supported over for this bearing is 300 mm. We can show it here in this form. So this is again we can show it in the scale 1:50. So 300 is a bearing support given below it. Hatch the section, will come to know how the support is given at the bottom here, and here. We can show it here. Scale is different here. We can reduce the scale here, so it will be easy if we still show it. So this is a pattern of slab here. So when the load is applied over this, how the bending will be there? What is the deflection of this slab? We can see here, we can take an arc like this from this end. As we did in analysis of indeterminate structures, whether determinate or indeterminate structures, even you have learnt in the design of portal frames, when we design the slab, what could be the bending, what will be the deflection in the slab. We can see here, we can take an arc here at this point, and if I show it like this in midspan and we'll join it, this is a way of the bending of slab takes place. I can show in the sagging movements here. So to avoid to this bending at the downwards, we need to provide the steel in this form, like this, which I am showing in magenta color. You can see here. This is nothing but a reinforcement I am thinking, and this should be given like this. So which will lift this deflection towards the upward. So the main bar is given at the bottom here. So we can shift it here. OP cover is given with 20 mm. So 20 divided by 50. This is what the bar I am getting. So let us consider this as this one. So this is a main bar provided at the bottom to avoid the bending of beam. And at the edge, as we know, it is supported over the bearings. This may lift the slab upward. So in order to make it contract, main bars are at supports, the moment will be negative at the top end. This, let us show it here. This is a positive moment at midspan. At the same time, the negative moment will be there at the edges, like this. In regular practice, we get the bending moment diagram in this fashion. Yes. So negative moment at the end spans and positive moment at the midspan. So main bars will be, positive moment will be there at the bottom of slab at midspan, and the same bars will be provided at the top end. At the end side, it will be on the top side, which will avoid, we can say here, I can give it like this here, again 20 by 50. So at a distance of 300 from support, I can show here, there will be a bend of bar of 45 degree, like this. Yes, we can see here. So 1 minute, I can show it like this. This is how we should show the bars here. So taking this, why she shown it like this means I will tell you. See, this is what the main bar reinforcement is given. We can see here at a distance of 300 from the edge, means the thickness minimum D we take, but here I am taking 3. Why means from this dimensions at a distance of 3 meter from support, the bar get bend here. We will bend the bar here and taken to the top side, where since the negative moment is there at the end supports, the main bars are given at the support point at the top. So which kind of bar will be bent here? How we will come to know which bar we should bend, which should not be bent here, like this. The main bars, both are main bars here. So only alternative bar. We can see from the diagram, it is very clear that maximum movement is there at midspan, and the movement at the support will be half of the midspan. So whatever bar provided at the midspan, half of that bar should be provided at the top. So if the spacing of main bar at the midspan is about, here it is given as tall at 150 mm, the main bars we are given here in this diagram. So tall at 150 is at a midspan here. We can see, I can show you in this here like this. This bar I am giving like this. Tall at 150, fine, we can see it here. I can take this point here and I can mention it here. The dimensions is too high here, we can say here. Shift the height here. So we can see the dimensions where I am showing, move here. Yes, the main bars are provided at 150 at the bottom here, we can see, and the same bar got bent at a certain distance from 300 from the depth, and at the top the reinforcement is given will be double. Means here we can see at the edges the main bar spacing will be 300. Means alternative bar get bent here, not all the bars. If you see in the plan, the main bars are provided in this fashion, like this. These are the main bars I am providing, which should be shown in the magenta only, because the main bars are in magenta color I am showing you, like this. The bars will be provided like this. I am not giving spacing here, but I am showing how it went. Here what happens, yes, the main bars are like this, but at a distance support from here 300, it is bent like this. Means I can show it like this, move. I can show it like this. it here, we can show it like this. Yes, this is how the bar have been placed here. Can you see? See every alternative bar. If we see at the bottom also, we get spacing as at midspan the spacing will be same, 12 at 150. When we come to edge, the main bars are at a distance of 150 and the 300. The spacing at the edges are 300. The spacing at this is also 300. 1,510 means 300. So at edges the spacing is 300. At bottom it is 150. This is how the main bars been provided here always. And in this term we got it. Next we come to distribution bars, which are provided here. Yes, we can see these are the distribution bars provided in this fashion. So let us give color for this as yellow, so that the detailing will be easy for you people. How we can show it here. This is how the main bar and distribution bar. Distribution bar you can see here, it will be placed like this all along the length in this fashion with certain covers. So the color of this will be yellow here. So this is a method of providing distribution bars. So in plan we can see, due to bending in like this become, the main bar is provided at bottom 12 at 150 mm. In the similar fashion at edges it is given 1 at, you can see here it is given like this. So the distance, the arrow will be 1 here, so we can show it like this. So 12 mm 150 at bottom and 12 at 300 at the edges. Similarly the distributions bar I can show it like this with even like this, guys. We can also show it here, and a similar fashion I can show it in this form also, where I get 8 at 150 as a distribution bars. This is what the section in the shorter span. When we go for the section at the longer span, similarly when I take a section like this in the longer span, if I show it like this, if I take a section along the longer span, what happens? The same thing, we can show the line here like this with the thickness of slab 150. So how the bar will be given, guys? We can show it like this, no problem. The bar will be again here, make sure that the main bar will be the distribution, that is 50 plus 12, that is 35 divided by 50. This will be main bar, which will be provided at the top with a yellow color. Yes, this is main bar, and distributions bar will be donut, which will be provided at the bottom. And this donut will have a color of magenta, so I can see. Yes, this is what we get. We can show the reinforcement. Main bar will be at the bottom and distribution bar will be at the top, that is shown in the section. This is what regarding one-way slab and a given slab thickness. The same thing I can show here, guys. The same I have shown how to draw here. The same thing we can see here. We have completed one 3 meter by 7 meters, and main bars are surrounded here, distributions bar here. The section taken at this here, I have shown here 3 meter section 150 thick, and the main bars at the bottom. The distributions bar being the hollow section when we for a shorter span. When we take for a longer span, again the main bars are been given at the bottom with the dotted lines, and the distribution bar will be a straight line at the top. So this is 8 at 150 and this is 12 at 150. This is how the reinforcement will be given. At the end support, again these distribution bars have been bent here, So that only we can see here. They are shown, not shown, but usually at the junctions where the main bar should be bent, that will be shown like this, and alternative bar will be bent here. So the spacing at the end spans will be 12 at 300, both at top and bottom. Even the bottom also, if you see, if we take liters at this point also, I can say this, like this I can write. The bottom bar will also be 12 at 300, because alternative bar get bent. So at top also we get the same thing, at bottom also we get the same thing, but only at midspan we get 150, and remaining at the edges at top and bottom you get 300, while the distribution at the top and bottom both will be at 150 mm center to center. So this is what we have learnt in the one-way slab. Due to bending of beam the slab in this fashion, we can see how the bar will be given at bottom and top. The same thing will be shown in the longitudinal section. We can see here, we have shown it here. So this is regarding the one-way slab. So one-way slab, show the hall dimensions clearly first, then the supported thickness wall 100 all around, the main bars, yes, positive reinforcement at midspan and negative reinforcement at the edges, all will be shown. So here the plan was given. This is a plan what I have shown, and this is a section for shorter span. This is a section for longer span, which is shown. The longer section you show it detailedly. I have shown it how it can be taken. Make sure that you complete the drawing while we send a PDF for you people to check it. And once you complete this, this is regarding the one-way slab. So when we say it is a one-way slab, when the longer span divided by shorter span is greater than 2, we got it as one-way slab. Then one-way slab is not only due to that, we can see the bending takes place only at the shorter span, while the bending in the longer span doesn't take place, because it's supported entirely with one of the member. So the span will be very less to bend it, so it will not bend in this fashion. Only bending takes place in the shorter direction. That's what main bar provided only at the shorter span on all along the length, and the distribution over that will be provided in the longer directions. Now coming over to the next part, let us take it. Let us consider the next part, one-way continuous slab. What is this one-way continuous slab? I think you have learnt more about one-way continuous slab in your syllabus, that is 7th sem. I think you have not come over this. When we design the portal frames, we design the one-way continuous slab. One-way continuous slab, when we say it one-way continuous slab, when the slab is continued over some of the supports. Because let us take example with one of the hall with the dimensions of about 5 meter by 20 meters or 25 meters. 5 meter will be the width of the slab, but length will be 25 meters. So entire 25 meter it cannot be slagged as a one-way slab, because it becomes indifficult for us to do. So at certain intervals the beams will be supported in the slabs. So when this will be given, it will cut down the length of slab. So 5 meter by something span will be given, that could be the act as a one-way. So these supports are given. What about bending moment? At every joints where the support is given, the bending moment will be at the top, negative moment will be created at the top of the beam, and remaining will be at the midspan. That we can see here. We can take one example, and I can show the diagrams how the deflection takes place in the slab, so that reinforcement will be provided at the top or bottom. So let us take one example of a continuous beam here. So prepare a continuous slab for a wall of 7 meter wide and L1.77 meters long with the following data. The center to center distance between the supporting beams is 3 meters. The span of the beam is 7.23 meters. Beam of supported walls, 0.23 thickness. The wall supported for the beams is 230 mm thickness of wall is provided, and the cross section of the beam is 230 by 450 mm. That indicates, since the beams are supported over the walls thickness of 230, definitely the wall width will be the beam width will be 230 only, depth with the 450. The grade of concrete they used is M20 and grade of steel they used is 415. A clear cover of 20 mm is given, while the slab thickness is 150 mm here. The beam depth is inclusive of slab, and the depth of beam 450 is given inclusive of the slab thickness of 150 mm. So the beam below the slab will be 300 mm depth, which is visible for us, and the depth of hall is given having walls on all the 4 sides. So the main reinforcement, main positive reinforcement at for end spans are 8 mm at 100 mm, while the main reinforcement in interior panels will be 8 at 400. We can make it 300. Usually the spacing should not be greater than 300, as we have learnt in the design of RCC, but here we have given 400. It is by mistake, I think. We can go with the 300 mm on both sides. So the main reinforcement at end spans are 8 mm at 100 mm center to center, and these main reinforcement for the interior panels will be of 8 mm at 300 mm center to center. The negative reinforcement at the supports are 8 mm at 300 mm center to center, and the distributions bar given are 8 mm at 200 mm center to center. So distributions bar given is 8 mm at 200 mm center to center, while remaining bars, main bars are given as 100 at 8 mm at 100 mm center to center, and at mid span it is 8 mm at 300 mm center to center. So as per the panels, depending upon the panel, the reinforcement has been changed here. So let us know, let us first draw a general layout, see that how it will be given. So width is given as 7 meter, we can draw here. So 7 meter width slab is given, which is having a length of L1 770 divided by 100. This is the length of beam, length of slab. So we can see here the dimensions are given here. I can write the hall is shown, which is having a dimensions of 7 by L1.77 meters. And as I told, all around surrounding it is provided with a wall thickness of 230. So let us provide a wall thickness of 230 all around. So let us take offset, that is 230 divided by 100, offset 230 divided by 100. So this is the supports. I can show you like this. So let us show these supports. I can show it in this diagram like this. Drawings are very simple, guys, but draw your own, so it will be easy for you to remember the things once you draw by yourself. So this I can show it like this. We can go with the property line and take AutoCAD. Scale will be of 10. Yes, this is what I can see here drawing. Wall thickness is given. So at from midspan of wall, from this midspan, we can see the length here like this. From this midspan, the beams are provided at 300 center to center, 3 meters. So at every 3 meters, 30, 60, 20. Yes, we can see these are the beams provided at every span. So this is a span of 3 meters, I can say, and we can write the dimensions in this fashion only. See how so easy it is. First show the outer dimensions, 7 meter by L1.77. Then show the wall thickness all surrounding with a 230 mm thick, where we get a support of beams. Next, the beams are being given at regular interval of 3 meters from center to center. So from this edge is 3 meter. So a 3 meter is for entire span we have given. 3, 3, 3, 3, 4, 6, we get 12. Means the wall should be at outside, I think. Okay. Every 3 meters is given here. Once we get this, we can see the beams are provided here with the dotted line. We can show the beams here. So we can take this as a center line, dotted lines, so that this will be center line. For this, beams will be given like this. So beams will be of 115 divided by 100 at this side, and 1.15 on this side. So this will be solid one. this is what the beams are given. We can copy this like this and paste on every point. You can paste it like this. You can see. So this is what the beams are provided in this fashion. So in this there are two internal panels and two are external panels. So what is given here? The beam size will be given. So beam size 230 by 450. Let us draw that also here only. So what slab thickness is given as 150 mm. So let us take first a slab here, some length. So let us copy and show the thickness of slab. 150 divided by something 25. We can show the slab thickness. And below this I can take one of the beam like this somewhere here and make 300 divided by 25 and 230 divided by 25. Then we close it. When we get a trap like this, then we continue this with like this. This indicates how the section of beam will be shown. We can show the beam section like this. Is it fine, Girish? Yes, we can see this shape of beam. So show the dimensions of beam here, which is 1:25. I think we have not taken anywhere here. 1:25. I think this is possible. We can show the dimensions. Sorry, we can show the dimensions here. We can see this is the section of beam shown, and here the next is the reinforcement. At the as the question they have given, the positive reinforcement at end span is 8 mm at 150. Yes, we can show the positive reinforcement in the shorter direction, so it will be like this. At the end, I told when we come over this, there will be bend in the beam like this, and it will be continued. So this is the main bar I am showing, which will be of magenta color. So this is main bar which we are showing here. Similarly, spacing of this main bar is diameter 1 at 100. 8 mm means 100. It is every distance we are giving it 100, 100, 300. Yes, we can see it is bent like this at the edges. Copy. The third one will be continued for the second one. Like this. Nice. Nice. And again at the edges we can see these two bars been copied here. Yes, this is what the main bars. At the end span, it is 8 mm at 200 center to 100 center to center. At mid span, middle interior panel, it is 8 at 300 center to center. And the distributions bars are given in this fashion like this. So this is a distribution bus, this is a main bus. This is what the reinforcement is shown in the continuous beam. Here we have shown all the reinforcement. Distributions were 8 at 200. We can write it, I think, unless we write it, it will be difficult for you people to understand exactly what is going on here. So copy, I can show it here like this. This I can show it as 8 at 150. At 150. Copy. At spin span it is 8 at 300. I can show it 8 at 300. And for distribution it is 8 at 200. So I can show it like this. Rotate it. So distributions I can show it like this. It is 8 at 200. Yes, this is what I have shown here. 8 at 100 at end spans, 8 at 300 at mid spans, inter panels, and distributions are 8 at 200 given in this section. This is what I have shown in the plan, and now I need a section for interior panels and main panels. Dimensions of the beam is also shown here, that is 1:25. You can see the dimensions. How to write these dimensions? I think 1:30 is there. Let us convert it to 1:20 or 30. So 25 divided by 20 I have shown here. So 1:20 if I take, I can write the dimensions here. This is 230, this is 300, and total depth is 450, thickness of slab is 150. This is how the section of beam is shown. A slab thickness of 150 mm, a beam with a depth of 450 by 230. In that 150 is been embedded in a slab itself. So a projection of this beam beyond the slab will be 300 mm. That I have shown. This is a section of your beam here, and this is a plan of the main continuous beam. So if you want, we can take a section on shorter direction and longer directions. We can see here in the longer direction, I can to show you one thing here. So how the bending moment will be there, that is main here. So this is a section I have taken. 1 minute, I will take a section like this. The same sections I will take here. I can show these are the supports given at this slab. Then how this slab behaves, I want to show you how this base actually behaves. What will the moment? We can take arc here like this. The moment will be like this. I can show you. So this is what the bending moment diagram we get, guys. In this fashion we get the bending moment diagram. So the main bars are provided like this at the center in the mid span, the main bars. This is the portion of main bar, while the main bar at the top will be given in this fashion, like this. So the same thing will be copied here. I can show this like this. These are the main bars. I can show all this in your magenta color, so it will be easy for you to remember. So remember this, why the reinforcement is given in this fashion. Main bars to avoid bending. So this is a deflection of the support. At supports we get a negative reinforcement. At midspan we get the positive reinforcement. That's what at positive the reinforcement will be higher than the distribution provided at the midspan. So here you can see midspan the spacing will be 8 by 100. While at the support it will be 8 by 300, because the moment at the edges are less compared to the midspan. So midspan the spacing will be more, less, and at the support it will be more. For this distributions, for bars are given to avoid the temperature cracks or to hold the beam in a slab in a contract way. This is main bars we have provided. The deflection of the slab will be shown in the figure directly, how it bends, how it is there. So the main bars are shown in the magenta color. For this the distributions bar will be shown in this fashion. Yes, these are the distribution bars I am showing. So I can show the distribution bars in this, like this. These are the distribution bars. I can show you like this. So distributions are shown like this, and since The bars are shown here. We can see the same diagram here. In this I given 8 at 100 at bottom, 8 at 200 at distributions. At top you got 8 at 300, 400 is not 400. We can say it as a 300, and this also I can take it as a 300. So we can show the reinforcement in this fashion. At mid span it is 8 at 100, at end span it is 8 at 300, and negative reinforcement at top at 800, 300, and here it will be 8 and 200 at distribution. So the same thing I have shown here. This is at 100 spacing. I can write with the letters like this. This is 8 at 100. Similarly, copy letters, and it will be at mid span. So mid span, what happens? This will continue like this, but at this point, some there section will be shown like this. It will be bent like this. So I can show it like this also. At 8 at 100, 8 at 200, 8 at 300. So this is 8 at 300. I have shown. Again, this is 8 at 300. This is 8 at 100. Yes, this is what I have shown. And distribution bars are 8 at 200. This is what the diagram is clear about your diagrams. Why reinforcement will be given at the bottom in the mid span, and why at top at the supports, because the bending moment diagram will be in this fashion, which we have designed in the analysis of continuous beam and analysis of continuous beam only I have done it. We will come to know. Depending upon this diagram, the reinforcements are provided. Here the dimension, the bar is not given in the beam, only beam dimension should be shown. A plan is shown with a section all along longitudinal shown here, plus a beam section is shown. This is what they have asked. And make sure that whenever the diagram is given, note down the diagrams, write down the dimensions properly with all the given data. Whenever a section is taken, take a section with a higher scale, while the remaining main will be the lower scale. So this is what we have learned, guys, in today's class, how to draw the one-way slab and one-way continuous slab. So I think it is very clear for you peoples, and I have sent the PDF will be sent for your links, and go through the links, draw by yourself. Make sure that to learn this CAD, the command should be very perfect. To have a commands over your commands, we need to practice more. So if you practice more, it will be easy for you to write in the exams. In exams, there will be 3 hours and 2 drawings will be given to draw, one for RCC, one for steel. And it means according to the timetable, you get 1.5 hours to draw this diagram. Since we have an experience of drawing here, I have completed drawing within no time. Within half an hour, I have completed the drawings, but everything should be shown in the scale here. Since we are having practice, we have completed, but not with the same thing with 2 peoples. So you need to practice more to complete drawing within 1.5 hours with the writing all the dimensions and the notes. So make sure that the further it will not make any hampering for you. So practice the things more, so that it will be easy for you people to connect the things. I think you enjoyed the class. Thank you.